my amazing students. This is Mrs. A, and we are doing 9.4, which is simplifying expressions containing higher roots. So the first thing we're going to do is just review the roots that we should know. Since 1 cubed is 1, the cubic root of 1 is also 1. Okay, the cubic root of 8 is 2. These are things that we should know. The cubic root of 27 is 3, because 3 cubed is 27. The cubic root of 64 is 4, because 4 cubed is 64. The cubic root of 125 is 5, because 5 cubed is 125. And the cubic root of 216 is 6, because 6 cubed is 216. All right, so those right there you should memorize. And now we're going to look at some fourth roots. Fourth roots climb much faster. The fourth root of 1 is 1. The fourth root of 16 is 2. The fourth root of 81 is 3. And the fourth root of 256 is 4. So those are also some that you should memorize so that you can do your work faster. And now we're talking about higher roots. So when we are using the fourth root and the fourth root, we can still use the the product rule. So we're going to put them together into one big fourth root. 3 times 8 is 24. And then we're going to look at it and say, okay, can I pull out any perfect fourths? And the smallest perfect fourth is 16, and 16 does not go evenly into 24. Therefore, I would leave my answer, the fourth root of 24. When I put these into one radical, I would end up with the cubic root of 21n. And 21n has no perfect cubes in it, and therefore I would leave it just like it is. So that's that one. On the next board, we have a cubic root of 81, and 81 is a perfect fourth. So I'm going to split this one into cubic root of 27 times the cubic root of 3. So I'm putting the perfect cube that is a factor of 81 into the first radical, and then the leftovers, so that these two still multiply together to give me 81. The cubic root of 27 is 3, and then I write on the cubic root of 3. The fourth root of 144. Okay, well then we know that 144 is 12 squared, but 12 is not a perfect square. So we're going to have a hard time with that. Let's go ahead and factor 144. We divide by 2 and we get a 72. We divide by 2 again and we get a 36. We divide by 2 again and we get an 18. We divide by 2 again and we get a 9. Okay, so we've got 9 is a leftover. We could break it up into 3 and 3, but it's still going to be leftover. And since we have 4 2's here, 4 2's is 2 to the 4th. So we're going to break this one up into a perfect fourth, which is 16, and the leftovers, which is 9. And this one will become 2 cubic root of 9. So 2 cubic root of 9 is the answer. Okay, so the next one, we have a radical, and I would not split that radical up because as it is, 3 does go into 48 evenly, and it goes in 16 times. So I can divide 48 by 3 and get the fourth root of 16. 16 is already a perfect fourth root, and when I pull it out, it is a 2. So this one had a benefit of staying together under one radical, okay? This one would benefit from being together under one radical. 56 is not a perfect cube, and 2 is not a perfect cube. When we put them all together under one radical, we get the cubic root of 56 over 2, and when I divide that out, I get a 28 is half of 56. So now I've got the cubic root of 28, and there are no perfect cubes that are factors of 28. So that would be my answer. Oops, I was about to erase this one, and I realized that I inadvertently went from a fourth root to a third root. That's a boo-boo. So I wanted to correct it so that you could see that was my mistake, that I had just slipped roots down an index. Okay, so that correct answer is 2 to the fourth power of 9, fourth root of 9 instead. All right, so these aren't so bad. We have a root and a 12th power, and we're going to remember our second rule of our higher powered was when we had a factor in our index and our power that were the same. We're going to just go ahead and write that as x to the 12 over 4 as a rational exponent. The 12 over 4 will cancel and give us x cubed. So as a radical, it would be out of the radical. There's nothing left because the root has disappeared. We were supposed to leave these in a radical form, but that one completely comes out of the radical. So no more radical form for that one. This one is perfect because 9 divides by 3 and 6 divides by 3. Now 12 divided by 4, and I ended up with a 3 when I put it into the rational exponent form. So the cubic root of 8 is already perfect. The cubic root of m to the 9 is already perfect. We pull it out as a 9 divided by 3, and 6 divided by 3 is 2, so we get an n squared. The next one, we're talking about our quotient rule. There is no benefit to having these together in one radical. So we would break this apart. 6th root of f to the 12th divided by 6th root of g to the 24th. Since 12 divided by 6 is 2, that would come out of the radical as f squared. This would come out of the radical as g to the 4th. And that would be simplified. This one we're going to have to break up into 2 different parts. So we're going to have my perfect radical and my leftover radical. So they're both fourths, but I'm looking for the largest multiple of 4 that's underneath or less than 31. So I'm going to put d to the 28th and d to the 3rd. So now the d to the 28th is going to pull out, since it's a fourth root, as a d to the 7. And then I just tack on the fourth root of d to the 3rd. And that would be my answer. This is my answer up here. So here we're going to have to split these up too, to a perfect fourth root and a leftover fourth root. So 32 does have a perfect fourth in it. 32 itself is a perfect fifth. It's 2 to the 5th. So we're going to put 16 in the perfect one and 2 left over in the other one. P to the 5th has got a P to the 4th in it, so we'll put the P to the 4th and then the leftover P on the other side, and Q to the 8th is already perfect. Okay, this one is a little bit big. Let me make it tinier so you know it's an index. So now this is going to come out as a 2pq squared and tack on the remainder radical right there. On this one, this is the first one where they're actually changing, they're giving us a fourth root and a square root that we have to multiply together. The only way to do this is to go to our rational exponents. So we're going to write m, the fourth root of m to the fifth, as m to the 5 over 4. And we're going to write the square root of m as m to the 1/2. And we're going to multiply these together, which means we're going to add their exponents. So I'm going to add together 5/4, and now I'm going to change the 1/2. I'm going to change the 1/2 to 2/4 because it is. And then 5/4 plus 2/4 is 7/4. We had m to the 7/4, okay? And now if I put it back into radical form, I end up with m to the fourth root of m to the 7th. Now, this is what I was talking about in the other one. We have to put these back into radical form, and that is not simplified radical form because I have a perfect fourth power. So to fix that, you would go ahead and either divide 7 by 4 and get 1 3/4 and put the 1m out, and the m to the 3/4 is a multiple of, like that. Or you could take this radical, fourth root of m to the 4th times fourth root of m cubed, and then you can see that this comes out, and we would have to write this as a radical. I forgot, we have to write this as the fourth root of m cubed. Okay, so this would also be m times the fourth root of m cubed. So that would be your answer down there. Again, we must take into consideration that we have a difference of 2 indices. All right, so I'm going to change this one to b to the 3/4. Change this one to b to the 1/3. I know when I divide like bases, I subtract their exponents, and I will get b to, what is 3/4 minus 1/3? I'm subtracting these. So I need to get to the 12th as a denominator. So 12, 12. If I multiply this one by 3, so I multiply this one by 3, I get 9/12. And I multiply this one by 4, I multiply this one by 4, and I get 9 minus 4, or 5/12. So b to the 5/12 would be that answer. So here we have a square root and a cubic root. So this is going to be x to the 1/2 times x to the 1/3, excuse me. Now I have to get a common denominator, so x to the 3/6 times x to the 2/6 is going to be, remember when I multiply like bases, I add their exponents and get x to the 5/6, and then I have to put it back under a radical, which would have been the 6th root of x to the 5th. And the 6th root of x to the 5th would be the correct answer. Okay, so we have one more that we're going to do, and that one is going to go on this board because I don't want to stop everything and restart again. So we got one more problem. I'm going to erase that one real quickly. And we've got the cubic root of x to the 4th divided by the square root of x. Again, two different roots. So we're going to take the one on the top and make it x to the 4/3. The one on the bottom is going to be x to the 1/2. We have to get a common denominator, and if we take 4/3, it is the same thing as what? 8/6. So this is x to the 8/6 divided by x to the 3/6. So when I divide like basis, I subtract their exponents, and I get x to the 5/6, which is the 6th root of x to the 5th. And that, I do believe, is the end of 9.4. And this is Mrs. A, and may God bless you. I only found one, boo-boo. This should have been turned back into, this was correct, but I forgot to turn it back into the radical form, which is what we were told to do. So that would have been b to the 5th, the 12th root of b to the 5th. So I should have turned it back into the radical, and I forgot to do so. Now I'm done.